This is Module 6, Lesson 3. We're going to be interpreting rate of change and initial value. We've been constructing functions to model linear relationships, and now we're going to take parts of those linear relationships, the rate of change and the initial value, and we're going to talk about what they actually mean in context of the particular word problem. Now, in your workbook, this is Lesson 2, Module 6, Lesson 2. It's rate of change. And we're going to start kind of here in the middle of the page. It gives us this one example here. It says, in a previous lesson, you encountered an MP3 download site. Hold on, let's get this straight so we can write with it. In a previous lesson, you encountered an MP3 download site that offered downloads of individual songs with the following price structure. $3 fixed fee for the subscription plus 25 cents per song. So here is our actual equation for this. Now what we know is that this fits a linear equation. Y is equal to mx plus b. B is your y-intercept. When we're talking about y is equal to mx plus b, b is your y-intercept. It's where it crosses the y-axis. It is also the beginning point. Okay, whenever you're plotting something, you start on the y-axis. It's where you would begin on that y-axis. Another way to describe it is the initial value. Okay, so we're talking about the initial value here, this B. What you start with $3 in the subscription fee, and then you add to it 25 cents per song, right? The M is our rate of change. Now, we've been talking about rate of change. Another way we describe that is slope, or we call that y over change in x. All of those things are your y or your m, your rate of change. So here what we've got is 0.25 is our rate of change. It always has something like a per or each or something like that. 25 cents per song. See, that gives us a rate of change. And X is our number of songs. Y would be the total amount that we're paying. This says, in your own words, explain the meaning of 0.25. Well, it tells you right here. It's 25 cents per song. 25 cents per song, okay? That's what you're going to be paying, right? 25 cents per song downloaded. In your own words, explain the meaning of the 3. Well, the 3 is our initial value. That is our flat fee that we're going to have to pay each month, right? Flat fee paid. All right, so you pay $3, then you pay 25 cents for each song that you download. And here it shows you in your book exactly how this is set up. It says the 0.25 is your rate of change. Your rate of change is always a per something, right? Your 3 is your initial value. It's where you start. So let's look at this. Is it a better deal? Another site offers MP3 downloads with a different price structure. $2 fixed fee for the monthly subscription plus a 40-cent per song download fee. Write a linear equation to model this where X is your number of songs and Y is your total monthly cost. Okay, so Y would be equal to, we start with mx plus b when it's a linear equation. And our fixed rate, our B is where we start. We start with $2. And then we're paying 40 cents per song. This tells us that this is our M. This is our rate of change. 40 cents per song. That per tells me all the time. That's a very good way to tell it. Per or each or something like that. Our equation says that the total amount we're going to pay each month is 40 cents per song times the number of songs we download, plus the $2 fee per month. Determine the cost of downloading 0 songs and 10 songs from this site. Here's what we're going to do. We're going to take both sites. We're going to use both sites. We're going to call this company 2. Okay, we're going to do both of them so we can compare. Okay, and I know they do this later on, but we're just going to do it here. I think it'll be easier for us to do it here. This is company 2. This is company 1. Company 2 charges us 40 cents per site. Okay, 40 cents per download times the number of songs downloaded plus $2. The other company was 25 cents per song that we downloaded, times your number of songs, plus a $3 flat fee. So on this side, we're going to do company one. With this side, we're going to do company two. How about 0 songs? Let's see what we'd pay if we were doing 0 songs. Let's try this equation. Y is equal to 25 cents per song times your number of songs plus $3. Well, if you've got 0 songs, that would be 25 cents times 0, right? Plus 3. 25 cents times 0 is 0. So Y is equal to 0 plus 3. What we pay for 0 songs is $3, right? Okay. It costs us $3 a month if it was 0 songs, right? How about from company two? Well, you can look at it and say, if I'm not paying any 40 cents extra, it's probably 2. But let's do the math and see. Y is equal to 40 cents per song times your number of songs plus $2. Okay. Y is equal to 40 cents per song times 0 songs plus 2. 40 cents per song, that's times 0 is 0 plus 2, and that, just like we said, is $2. Okay. How about 10 songs? Well, let's try it for both of these. If we've got 10 songs, you've got Y is equal to 25 cents per song times your 10 songs plus 3. That would give you $2.50 plus 3, which would be $5.50. It would cost you $5.50 if you downloaded 10 songs with this service. Let's try this one. Total cost is equal to 40 cents per song times 10 songs plus $2. Okay. 40 cents times 10 would give you $4 plus $2. That would give you $6. It would cost you $6 to download it with this company. This one would be cheaper, wouldn't it? Okay. The graph below already shows the linear model for the first subscription. Graph the equation for the second one. Okay. So we start with $2, don't we? We start at $2. Then we're going up 40 cents per song. It told me right here that if I download 10 songs, it's $6. So let's just go to the $6. $6 for 10 songs. Okay, now let's draw our line between. We started at $2, going up here to $6, right? There we go. All right. This is company two. Let me make this so we can read it. So let's answer some questions here. All right. First off, which company is cheaper if you've got 10 songs? Wouldn't that be company one? See, it's a little bit below. Let's see, this would be $6. This would be less than $6, right? Which company is cheaper if you've got 3 songs? It'd be company two, because 3 songs would be a little bit more than $3, and this one's almost $4, isn't it? Okay. About where would you have the same price? Close in here, somewhere between 7 and 8 songs is where you have the same price, right? Okay, let's look at the other questions that they've got down here. They say, which line has a steeper slope? Okay, let's go back and look at it. Steeper slope is company two. How do I know that? It's 40 cents per song instead of 25. And then the other question was, which function has a greater initial value? Well, the initial value here was 3 on company one, because it started out at $3. This one starts at 2. Okay, so that explains those two. Let's look at the next page on this, I think it is. This is all in lesson 2. Exercise 1 through 6. Is it a better deal? Another site offers MP3 downloads with different price structure. A $2 fixed fee. Okay, no, we've already done this one. We did that. We just did that. Sorry. Hold on. Exercise 7 through 9 in lesson 2, aging autos. When someone purchases a new car and begins to drive it, the mileage, which is the number of miles the car has traveled, immediately increases. You start driving it, so you get miles on it. Let X represent the number of years since the car was purchased, and Y represent the total miles traveled. The linear function that models the relationship between the number of years since purchased and the total miles is Y is equal to 15,000 X. Now remember, a linear equation, Y is equal to mx plus b, isn't it? Okay. They want us to identify and interpret the rate of change. What is our m here? It's 15,000, isn't it? Okay, what does it mean? Well, we know that our m is our change in y over our change in x. Our y represents total miles traveled, so that's miles traveled, right? Our x represents number of years, doesn't it? So let's look at that. This is 15,000 miles per year, isn't it? See where I got the units for that? I found what my change in y was. My y is my total miles. My change in x is on the bottom. The x is years, miles per year. So this says that this car is going to be driven about 15,000 miles per year. Car will be driven 15,000 miles per year. See that per, again, we're talking about our rate of change. When you see a per or each or something like that, you're dealing with rate of change. Identify and interpret the initial value. Well, our initial value is B, but there's nothing added here. What can I add and not change it? 0. Okay, when you see nothing there, it means it's plus 0. And doesn't that make sense? Because we're talking about the number of miles. A new car, wouldn't it supposedly have about 0 miles on it? You start at 0 miles, you add 15,000 miles per year, multiply that by the number of years, it tells you total how many miles you got on there, right? So your initial value is 0. What does that mean? The car has 0 miles on it, what, when you purchased it, right? When it was purchased. Perfect. Is the mileage increasing or decreasing each year? Well, this is positive. It says, our equation literally says the total mileage, because that's what y is, represents total miles. The total miles is equal to 15,000 miles per year times the number of years plus 0 miles, right? The mileage is increasing by how much? It is increasing by 15,000. How do we know it's increasing? We know it because our slope, our rate of change is positive. The rate of change is positive. When the rate of change is negative, something is decreasing. Okay? All right, let's look at the next question, number 8. When someone purchases a new car and begins to drive it, generally speaking, the resale value of the car goes down. What's another term for goes down? Decreases, right? Okay. And it decreases each year. Let X represent years, number of years since purchase, and Y represent resale value. Okay. Here's the linear equation that models the resale value based on the number of years, okay? X is years, Y is resale value. Let's write this over here so we can see it. Y is equal to 20,000 minus 1,200X, okay? So identify, interpret the rate of change. Well, you're going, wait a minute, that doesn't look like what we're used to seeing, y is equal to mx plus b, because there's no variable here, is there? What they have done is they have changed the place of the rate of change in the variable and the initial value. They swapped their locations. You can do that. That's commutative property of addition. All we did is we swapped their places. So you could also have written this as y is equal to negative 1200x plus 20,000. See, I swapped it back for you so you could see it, how it could look, right? So what is your rate of change? It's whatever is in front of the variable. Here's your variable. It's negative 1200, right? Negative 1200. And what does that stand for? Well, we're talking about the value of this car going down. Okay, so if negative 1200 is our m, that's our change in y over our change in x. Our y is the resale value, okay? That's resale value in dollars, isn't it? Right? And what is our x? What does it say our x is? Our x is years since purchased, right? This is the years, okay? So what we're doing is we're going down what? $1,200 on resale value, what? Every year. Isn't that what this tells me? Cars resale value goes down $1,200 each year. Okay? Identify, interpret the initial value. The initial value, well, that would be your B. That's 12,000, right? And what does that mean? Well, if we're talking about the resale value of the car, wouldn't this be where the car started? Well, isn't that the original value of the car? $20,000. Original value of car. That's where it started, the initial value. Is the resale value increasing or decreasing each year? Well, what does our slope say? What does our rate of change say? It says negative 1,200. If we were to plot this, this is start at 20,000. And it'd be going down about 1,200 each year, right? Okay. So is the rate increase, is the resale value increasing or decreasing? It's decreasing because our rate of change is negative. It is decreasing. Why? Rate of change is negative. Okay? All right. Let's see. Now we're going to look at the exit ticket for this particular unit. It says in 2008, a collector of sports memorabilia purchased 5 baseball cards as an investment. Let Y represent the card's resale value. Y. And I'm just doing this so you can see it easily. Cards resale value. What is our X? X represents number of years since purchased. X is our years, okay? Each of the cards' resale values after 0, 1, 2, 3, and 4 years can be modeled by the linear equations as shown. Okay, well, let's look at these linear equations. Do they look like what we're expecting from a linear equation? Y is equal to mx plus b. Let's just pull one of them out and see. Y is equal to 5 minus 0.7x. No, it's got the variable here, and this one's got the variable here. Can I use my commutative property of addition to move these around? Y is equal to negative, see the negative goes with it, negative 0.7x plus 5. If I'm looking at that, what's my B? What's my initial value on this one? It's 5. That means that's where I started out. What's the value of the card? That's what the value of the card was when I bought it. But then what's happening? It's going down 0.7, which is, look, 0.70. Isn't it going down 70 cents each year? Change in Y over change in X. My M is change in Y over change in X. That would be the card's resale value. That's money per, what's my change in X? Years. So it's going down 70 cents per year, right? Okay. So let's look at each one of these. Which cards are decreasing in value each year? Well, we need to look at their rates of change. What's in front of the variable? Okay, in all of these, they put the B first, the initial value first, and they put the rates of change. See the variable behind it? They put the rates of change over here. Which ones are decreasing in value? The negative ones. This one, which is card A. Oh, and this one, which is card D. So A and D are decreasing. Why are A and D decreasing? How do we know that? Because their rates of change are what? Are negative. If you talk through what it means, it started at a value of $5. It's going down 70 cents each year, right? So its value would be worth $5 minus 70 cents each year times the number of years since you bought it. Which card had the greatest initial value at purchase? Okay. Which ones had the greatest initial value? Well, initial value is the B, right? In this case, they put the B in the front. Card C and card D, right? Okay, because both of those are 10 and the other numbers are smaller. Which cards are increasing in value at the fastest, with the fastest rate from year to year? How can you tell? Well, now we're looking at the rates. Which one's increasing faster? This one's decreasing. That one's increasing at $2.60 per year. This one's increasing at 90 cents per year. This one's going down $1.10 per year. This one's going up 25 cents per year. So B is the one that's going up faster, right? Its rate of change is bigger than everything else. Has largest positive rate of change, right? And why did I say positive and not negative? Because the negative would be going down in value, right? It's got a positive rate of change, then it's going up in value, all right? If you were to graph the equations of the resale values for cards B and C, which card's graph line would be steeper? Well, let's look at B and C. B is going up $2.6 per year. C is going up 9/10 of a dollar per year. So B is going up faster, isn't it? Okay. B, why? Its slope or rate of change is greater than card C's, right? Write a sentence explaining the 0.9 value in card C's equation. 0.9, okay? Our total value at any given time is equal to 10, which is what we started it with as its value, plus 9/10 of a dollar per year times the number of years. So it's going up about 90 cents per year, okay? 0.9. Card C. Card C's resale value goes up. 0.9 is 90 cents, right? 90 cents per year. Okay, that's what that means. Now let's look at some of these problem set numbers, okay? A rental car company offers the following two pricing methods for its customers to choose from for a 1-month rental. Method 1, you just pay $400 for the month, okay? So 1 is just a flat $400 fee. Method 2, okay, you pay 30 cents per mile plus a standard maintenance fee of $35. Let's write the linear equation for it, okay? So what you're going to pay is equal to, you start with mx plus b. What is our m, our rate of change? 30 cents per minute. That per tells you right there that's your rate of change. 30 cents per minute times your number of minutes plus b, $35, okay? There we go, 30 cents per minute times the number of minutes plus $35. Now, that being the case, if you plan to drive 1,100 miles for the month, which method would you choose? Well, let's plug this back in. Y is equal to 30 cents per minute times 1,100 miles plus 35, okay? Y is equal to 30 cents a minute times 1,100. If you put that into your calculator, 1,100 times 30 cents, that's $330, okay? Plus $35 would be $365, right? $365. This is $400, okay? Which one's cheaper? Number 2, okay? Recall from a previous lesson that Kelly wants to add new music to her MP3 player. She was interested in a month subscription site that offered its MP3 downloading service for a monthly subscription fee, plus a fee per song. The linear function that modeled the total monthly cost is shown here. Y is equal to 525 plus 30 cents per song times your number of songs. The site has suddenly changed. The linear function that models the new total monthly cost in dollars based on the number of songs downloaded, X, is Y is equal to 35 cents per minute times the number of minutes plus a $4.50 flat fee. Explain the meaning of the $4.50 in the new equation. If you look at what a linear equation is, Y is equal to mx plus b. That's your b. That's your initial fee. So $40.50 is your initial fee, okay? Is it a better situation for Kelly than before? Well, look, guys, this is not Y is equal to mx plus b. These have been swapped. So this equation is actually Y is equal to 30 cents per minute times your number of minutes plus 525. Okay? All right. Now, 525 is what your initial fee is here. 450 is what your initial fee is here. Okay? This one has a lower initial fee. This one has a higher one. Explain the meaning of the value 35 cents in the new equation. Is this a better situation for Kelly than before? No, this would be worse. This would cost more than the per fee, right? Per download fee. If you were to graph the two equations, which line would have a steeper slope? This one would have a steeper slope. What does this mean in the context of the problem? This means that this one's rate goes up faster. It starts lower, but its rate goes up faster. Which subscription plan provides a better value if Kelly downloads fewer than 15 songs per month? So let's put it in as 14. Y is equal to 30 cents per song times 14 songs plus 525. If you go through the math on that, 30 cents per song, 0.3 times 14, and add 525 to that, you get $9.45. Here, y is equal to 35 cents per song times 14 songs plus 450. Okay, 35 cents per song times 14 songs plus 450, and that would give you $9.40. Okay, which one is a lower price? This one with the $9.40. Okay, now let's look at lesson 3, representations of a line. A truck rental company charges a $150 rental fee in addition to a charge of 50 cents per mile driven. In this problem, you'll graph the linear equation relating the total cost of rent and rental dollars C to the number of miles driven M on the axes below. Okay, so first off, let's do that. I want to write the linear equation first. I think that's actually D. So here's our answer to D. We start with y is equal to mx plus b. What's our initial fee? $150. Okay. Now let's take care of our m. It's 50 cents per mile driven. 50 cents per mile driven times your number of miles driven. Okay. Here's our equation. We start at 150. Now, we're going to go up 50 cents per mile. Problem is, that's going to be an awful lot of miles to drive to try to do, and we don't have a 1 down here. So let's find something we can plug in and find another point. How about we plug in the 1,000? Let's see what it is for 1,000 miles driven. If y is equal to 50 cents per mile times the number of miles plus 150, then the total amount we would pay would be equal to 50 cents per mile for 1,000 miles plus 150. That would be 500 plus 150, which would give me $650. Okay, there we are, $1,650. Okay. If the truck is driven 0 miles, what will be the cost to the customer? $150, right? Because it's 0 miles, it's $150. We're going to draw our line through here. At 0 miles, it's $150. Where is this shown on the graph? It is the y-intercept. What's the rate of change that relates cost to the number of miles driven? Explain what it means within the context of the problem. The rate of change here, what is our M? It's 0.50. 0.50. What does it mean? Well, let's go up here and see. We know that our rate of change is change in y over change in x. What are we talking about? Let's see. And we could have written it this way. They said the cost to rent it would be C. So C would be 50 cents times your number of miles, M, plus 150. See, all we did there was change out your X and your Y for C and M. You can use any variables you want to. Here they said C was your rental cost in dollars and M was your number of miles. But let's say we got our change in Y over change in X. Let's see. Or in this case, Y is C. This is your cost in dollars, so that's dollars per mile, right? M is mile. That's dollars per mile. So what does this mean? This means it's 50 cents per mile. And you could have gotten this also by looking straight up here, where it said that it's 50 cents per mile driven. It gave it to you right there. It told you what it was. Now, we've already done all of this. We've already done our linear equation, and we've written our equation for it. Okay? Let's go to the next one. Jenna bought a used car for $18,000. Okay. She's been told that the value of the car is likely to decrease. This is called depreciation by $2,500 for each year. See, that's like per year, right? $2,500 per year. That tells you that's your rate of change, right? Let the value of the car in dollars be V, and the number of years she owned it be T. Okay? Now we can start with Y is equal to MX plus B. We're talking about the value of the car, which is on your Y-axis. That would be V. Okay? Here's your rate of change. Your X, number of years, is called T plus B. What is our rate of change? It's $2,500, but it says it's going to decrease by $2,500. Doesn't that mean that it's going to go down? Isn't that negative? So my value is going to be equal to negative 2,500 T plus, where did I start? 18,000. That's my B. Okay? That's my initial value. Here's my rate of change. Here's my initial value. What is the value of the car when T is 0? Well, if T is 0, that's times 0. Let's try. Value of the car would be negative 2,500 times 0, that's 0 years, plus 18,000. Okay, that's 0 plus 18,000, so that's $18,000. Or you could have just said, what's the value of the car when you start? Because that's when T is 0. It's 18,000. So we could plot this. Let's see, it's 15, 16, 17, 18. That's where we'd start, wouldn't we? What is the rate of change that relates V to T? Is it positive or negative? How can you tell? Here's our rate of change. It's negative 2,500. Now, that's negative 2,500 what? Well, let's think about it. Our M is our change in Y over our change in X. That would be dollars on the Y-axis, and X is years, right? So we're talking about this being going down $2,500 per year. Is that positive or negative? It's negative. How can you tell? Because the value decreases, right? And if it decreases, that means that your slope is negative. Find the value of the car when T is 1, T is 2, and T is 7. T is 1, okay? Well, at time 1, would we put in 1 to our equation? Y is equal to negative 2,500 T plus 18,000. Let's see. Value equals negative 2,500 T plus 18,000, okay? Now let's put in 1 for that. So value would be equal to negative 2,500 times 1 plus 18,000, right? Negative 2,500 times 1 would be value is equal to negative 2,500 plus 18,000. So you're saying 18,000 minus 2,500. Your value would be 15,500, right? Okay, after the first year. In fact, I'm going to plot this up here. At the first year, the value is going to be 15,500. So that would be right about there, right? Okay. What about after the second year? That value is going to be equal to negative 2,500. It's going down $2,500 each year for 2 years. It started at 18,000, didn't it? Okay. So the value is that we're going down 5,000. We're starting at 18,000. The value then is 13,000. Okay. So after 2 years, the value is at 13,000. 2 years, 10,000, 11,000, 12,000, 13,000. Okay. And then after 7 years, your value is equal to negative 2,500 times 7 plus 18,000. So if you multiply negative 2,500 times 7, that is negative 17,500 plus 18,000. And that would give me that the value is 500. So my value at that point, after 7 years, is 500. Okay, that would be 1,000. It'd be right about there. Okay, so you're talking about a line that looks like this. Okay? See how it's decreasing? See how its slope is negative? All right. See, did they ask us anything else? And we did plot the points, write the linear equation. Okay, we've already written the linear equation. It's up here. Okay. Let's look at the next one. An online bookseller has a new book in print. The company estimates that if the book is priced at $15, then 800 copies of the book will be sold every day. So if it's priced at $15, 800 copies would be sold. I'm going to put a point there. They gave me a point. And if the book is priced at $20, price the book $20, then 550 copies would be sold. So 550. Okay, gosh, I can plot that because they gave me 2 points this time, didn't they? Okay, I'm going to go from this through there. Okay, line should look like that, shouldn't it? They gave me 2 points. I don't have to, I can just plot what's there. Identify the ordered pairs given in the problem. We've got 15 and 800. And I know it's 15 because see the x-axis has got that. That's the x, 15 and 800. And then 20 and 550. And I've already plotted those. Assume that the relationship between the number of books sold and the price is linear. Okay? Use a straight edge and draw a line. We did that. What's the rate of change relating number of copies sold to price? Well, we know a rate of change is our m is equal to change in y over change in x. If this is our x and that's our y, this is our x and that's our y, we could set up our table because I think y'all are more comfortable with the table. When the x is 15, your y is 800. When the x is 20, your y is 550. So change in y would be 550 minus 800. Okay, you don't always start with the big one, guys. Doesn't matter, okay? Just as long as whichever one you start with, you keep the same corresponding x. See, 20 and 550 are parts of the same coordinate pair. So 550 came first, 20's got to come first. 20 minus 15. 550 minus 800. Make sure you use your calculator so you don't make any mistakes. 550 minus 800 is equal to negative 250. Okay, 20 minus 15 is 5. 250 divided by 5 is negative 50, okay? So their slope is negative 50. So what does that mean? Because we know our y's over our x. Change in y over change in x. That's negative 50. That means you go down 50 copies per dollars that you go up in price. Down 50 copies per $1 price, okay? Price increase. Based on the graph, if the company prices the book at $18, about how many copies can they expect to sell per day? Well, 18, it'd be about 750, right? Okay. About 750, okay? Based on the graph, approximately what price should the company charge in order to sell 700 books per day? Well, if I want to sell 700 books per day, I probably should sell the book for $17 a copy, right? Okay. So you can look at the chart and find those answers. And the next one. A plumbing company charges a service fee of $120 plus $40 for each hour worked. In this problem, you'll sketch a graph with a linear function relating the cost to the customer in dollars C. Okay, so C is our Y. About to the plumber in hours T. So T is our X, right? C is our Y, T is our X. If you start with Y is equal to MX plus B, C is our Y, T is our X. He charges a service fee of $120 plus $40 for each hour worked, okay? See, $40 for each hour. That's $40 per hour. When you think of it that way, 40 is your rate of change. That's $40 per hour. It's written out here for us, so we know what it is. Times the number of hours plus our initial fee, which is $120, okay? If the plumber works for 0 hours, what will be the cost to the customer? Well, if you put in 0 there, 40 times 0 is 0. Our initial cost is $120. 20, 40, 60, 80, $120. That's where we're starting, right? How's that shown on the graph? Isn't that the y-intercept? It's where we start, isn't it? What's the rate of change? 40. $40 per hour. Write a linear function that relates this. C is equal to 40t plus 120. Find the cost of the customer if the plumber works the following number of hours. Well, 1 hour. Okay, that would be C is equal to 40 times, our time is 1 hour plus 120. That would be 40 plus 120, which is $160. 2 hours. C is equal to 40 times 2 plus 120. 40 times 2 is 80 plus 120 gives me $200. How about 6 hours? Cost is equal to $40 an hour times 6 hours plus 120. 40 times 6 is 240 plus 120. Okay, and that would be $360, right? There you go. Place the points for these times on the coordinate plane and plot them. Let's see. This would be 1 hour is $160. Okay. 2 hours is $200. 6 hours is $360. Okay, let's put those on there. 1 hour is $160. See, this is 120, 40, 60. 2 hours is $200. 6 hours is $360. 6 hours is $360. Let's see, that's 300, 20, 40, 60. Okay, all I got to do now is put my line through it, right? Okay. And this one says, an author is paid a writer's fee of $1,000 and will additionally receive $1.50 for every copy of the book that is sold. Sketch the graph of the linear equation. So first let's write the linear equation. Y is equal to mx plus b. What he gets to start with is $1,000, so that's our b. Then he gets $1.50 for every copy. Y is equal to 1.50 x plus 1,000. Now he's saying that his y is going to be called a, that's the amount he gets, and that his x is going to be called n, that's the number of books. Okay, so there's our equation. What's the rate of change? $1.50. Okay, he's going to get $1.50 per book, right? What's the initial value? $1,000. Let the number of books sold be n, the total amount A, construct the linear equation. We did that up here. A is equal to $1.50 per book times the number of books plus 1,000. Okay? And then the last one, let's look at. Suppose that the price of gas has been falling. So that means this is going to go down. At the beginning of the month, T0, the price was $4.60 per gallon. Okay? So at time 0, see, X is our time. At time 0, it's $4.60. 20 days later, that would be day 20, the price is $4.20. Assume the price per gallon P fell at a constant rate over the 20 days. We start with Y is equal to MX plus B. Okay? Where did it start? It started at day 1 at $4.60. Okay, so we put that there. It's falling. We need to find the M. Okay? Our M. Change in Y over change in X. Here's our X and here's our Y. When our X is 0, our Y is $4.60. When our X is 20, our Y is $4.20. Change in Y here would be $4.20 minus $4.60 over 20 minus 0. That would give me, let's see, negative 40 cents over 20. If I divided 40 cents by 20, use your calculator so you don't mix it up, you would get 2 cents. Goes down 2 cents, okay? So it's going down 0.02 cents per day, okay? So this becomes negative 0.02. Okay, let's write it better. Y is equal to negative 0.02 X plus 460. Okay, now our Y is P. The price is equal to, and it's going down 2 cents per day times your number of days, and it started at 460. That's just what that means. Identify the ordered pairs. We did that. Plot them on the graph. Let's see. 0 is 460. Okay, 20 days is 420. All right. Now, we've got those 2 points. What we need to do is connect the 2 points to create our line. So we're just going to connect the 2 points to create our line. Hold on. Let me get our pin functioning. Let's set up our line and let's bring it from 460 down to, oops, I didn't do our line, but okay, it's close enough. All right, that would be our line. Let's see if we can actually get our line working. It would start at 460 and would go down to 420. That's what our line should look like right there. Okay. Now, let's see what this says. It says, let's see what questions it asks us. It asks us, first off, we've done our ordered pairs. We've used our straight edge. What's the rate of change? The rate of change is negative 0.02. That means the price goes down 2 cents, which is 0.02 per day, right? Okay. What's the function that models the relationship? We did that. P is equal to negative 0.02t plus 460. What was the price of the gas after 9 days? Okay. You could plug that in. That would be, price would be equal to negative 0.02t plus 460. Okay. Plug this in as 9. Okay. That would be negative 0.02 times 9 plus 460. That would be negative 0.18 plus 460. So I would subtract 1/8 from that, and that would give me 442. Okay. How many days was the price? After how many days was the price 432? So let's plug it this way. 4.32, plug this in for P, is equal to negative 0.002T plus 460. Okay, we'll subtract 460 from each side. When I subtract that from each side, I wind up with negative 0.28 is equal to negative 0.02T. So I've got to divide both sides by negative 0.02. Divide both sides by negative 0.02. Okay. And that would give me the number of days before it is 432. Okay. Hold on, let me grab my calculator. Okay. And we will divide negative 0.28 by negative 0.02, and that would give me 0.28 and that should give me 14 days. Let's look and see. Would that be about right? 14 days, 4.32. That makes sense. That would be 14 days. Okay, that covers all of that. We have now found the rates of change and the initial values, and we've talked about what they actually mean.